Hello everyone. Today we are starting with class 7th maths curriculum. We are already having videos on all the topics of class 8th, 9th and 10th maths curriculum. Along with that, we are even having videos for the competitive examination. So today we will be starting with one of the important topic of the number system, that is your integers. So let's recall what number systems is. So first of all, let's understand what is natural number. We have already learned about natural numbers. Natural numbers are denoted by capital N. And when we are taking the group of all the counting numbers which are starting from 1, we are getting a set of natural numbers. Like if we are going to take 1, 2, 3, 4, up to the number whichsoever comes in our mind, if we are taking the set of all these numbers, it is your natural numbers. Then comes your whole numbers. So whole numbers are denoted by capital W. And if we are going to take 0 along with all the natural numbers, we are getting the set of whole numbers. That means whole numbers are 0, 1, 2, 3, 4 and up to the number whatsoever comes in our mind. If we are going to take all these numbers together, we are getting the set of whole numbers. Then comes your integers. Integers are denoted by capital Z. If we are going to take all the natural numbers, 0 and all the negative of the natural numbers together, then we are getting set of integers. That means if we are going to take say minus 3, minus 2, minus 1, 0, 1, 2, 3 in both the direction up to the number whatsoever comes in our mind, if we are going to take all these numbers together, then we are getting set of integers. Over here towards the right of the 0, all these numbers are known as your positive integers. These are your positive integers. Whatsoever the numbers are there towards the right of the zeros are positive integers, and whatsoever the numbers are there towards the left of the 0 are known as your negative integers. These are your negative integers, and 0 is neither positive nor negative. It is even an integer, but it is neither positive nor negative. So if we are going towards the right up to infinity, all these numbers are your positive integers, and if we are going towards the left of 0 towards the left in the left hand side to up to infinity, then we are getting negative integers. So all these together are known as your integers. These are positive integers, these are negative integers, and 0 is neither positive nor negative. In our previous classes, we have learned how to add and how to subtract the integers. So in this video, we will be learning how to multiply and how to divide the integers. So first of all, let's understand how to multiply the integers. Suppose we are having any two integers, say A and B are the two integers, and we have to multiply these two integers. So there are two conditions. One of the condition is if both the integers have same sign. If both the integers are same sign, this is one of the condition. That simply means if we are taking A as one of the integer, B as one of the integer, if suppose both these integers are positive. That means I am taking an example. Suppose we are taking 2 multiplied by 3. Here 2 is positive and 3 is even positive. If we have to multiply these two, simply we will be taking its numerical values and we will be multiplying, and the answer will be 6. The answer will be positive if both the numbers which we are multiplying are your positive. Similarly, if we are going to take the two numbers which are negative, we have taken one of the number as minus 2, another number we have taken as minus 3. That means we have taken two integers and both the two integers are negative. In that case, what we will be doing is, first we will be multiplying these two numbers, 2 and 3 numerical values we will be multiplying. 2 multiplied by 3 will be your 6, and the answer will be plus 6 if both the numbers which we are multiplying are negative. That simply means if we are multiplying any two integers and both the integers are having same signs, then our product is also positive. If both the integers are positive or both the integers are negative which we are multiplying, then the product is positive. Suppose one more example I am taking. One of the number is say 5 and another number is 6. Both the numbers are positive. If we will be multiplying these two, 5 into 6 is 30. So product will be 30. Instead of this, if both the numbers are negative, One of the integer we have taken as -5, another integer we have taken as -6. Here both the integers are negative, both the integers are having the same sign. So first of all, we'll be multiplying the numbers. 5 into 6 will be 30 because both the numbers are negative. So product will be positive 30. That means if we are multiplying one positive number with another positive number, the product will be positive only. If we will be multiplying a negative number with a negative number, then also the product will be positive. Now the second condition is if both the integers have different or opposite sign. Different sign. That means one of the integer is positive and another integer is negative. Say if we are going to multiply 2 and -3. Here one of the integer is positive 2, another integer is minus of 3. One is positive, one is negative. So what the answer will be? Here first of all we will be multiplying the numerical values, that is 2 multiplied by 3 will be your 6. But because one of the number is positive and another number is negative, so that's the reason our answer will be, our product will be minus of 6. Similarly, if suppose it is -2 multiplied by 3. One of the number is -2, another number is your positive 3. That means one number is negative, one number is positive. Then also the answer will be minus of 6. Here 2 multiplied by 3 will be 6, and because one of the number is negative and another number is positive, so final product will be a negative. It does not make a difference that which number, that means bigger number is positive or the smaller number is positive. If any of the number is positive and another number is negative, then always the product will be negative only. Simply the numerical values will be the product of these two numbers and the sign will be your negative. Similarly, we will be taking one more example. Say minus of 5 multiplied by say 7. Here one of the number is negative, another number is positive. So 5 7 is 35 and answer will be minus of 35 because one of the number is positive and another number is negative. If we are going to multiply 5 by -7, then also the answer will be, the product will be your minus of 35 because 5 7 is 35 and one number is positive and one number is negative, so final answer will be negative only. So that simply means we can conclude, if we are going to multiply a positive number with a negative number, then product will be your negative. If the first number is negative and the second number is positive, then also your product will be negative. So whatsoever the number is positive and whatsoever the number is negative doesn't make a difference. If one of the number is positive and another number is negative, then always and always our product will be negative. Hope it is clear how to multiply any two integers. If we are going to multiply any two integers and if both the integers are having the same sign, that means if both are positive or both are negative, then our product will be positive always. If we are multiplying two integers with different sign, that means if one of the integer is positive and another integer is negative, in that case our product will be negative. So we'll be seeing the properties of multiplication now. Now let's understand various properties of multiplication of integers. So first property is your closure property. So multiplication of integers satisfy your closure property. What does that mean? If there are two integers, suppose we have taken two integers, one of the integer is a and another integer is b. These two are the integers. If we are going to multiply these two integers, the product will always be an integer only. Whatsoever the number of a is there, whatsoever the number of b is there, if these two are any of the integer, the product of these two will always be a integer. Let's understand it. Suppose one of the example we have taken is, one of the integer we have taken as minus of 5, another integer we have taken as minus of 10. These two are the integers. If we will be multiplying these two integers, the product will be your plus of 50 because both the two integers are negative. So when we will be multiplying, the answer will be, the product will be positive. And 50 is even an integer. So whatsoever the value of a is there and whatsoever the value of b is there, if these two are any of the integer, the product will even be a integer. So we will be saying that multiplication of integers satisfy your closure property. The second property is commutative property, that is even known as commutativity. Now what does that mean? If there are two integers, one of the integer is say a and another integer is say b. If we are going to multiply these two, whatsoever the product will be there, it will be equivalent to b multiplied by a. That means if we are going to change the order of the integers, then the product will remain same. Example, we can say if we are going to multiply 2 multiplied by 3, and if we are going to multiply 3 by 2, over here the product will be 6, over here also product will remain 6. That means if we have taken any two integers and if we are going to multiply these two, the product will be same as if we are going to change their order. If we are going to change the order of the integers, then also the product will remain same. So we will be saying that multiplication of integers satisfy commutative property. The third is your associative property, that is even known as associativity. Now here we are taking any three integers. Suppose a, b and c are the three integers. We have taken three integers. One is a, another is b and another is your c. So according to associative property, a multiplied by b multiplied by c will be equivalent to a multiplied by b multiplied by c. That means if we are going to change the grouping, in this case we will be multiplying b and c first. Whatsoever the product will be there, we will be multiplying it by a. So what the final answer will be, it will be equivalent to, if we will be multiplying a and b first, and then whatsoever the product will be there, we will be multiplying the product by c. In both the cases, your product will be same. So we will be saying that multiplication of integers satisfy your associative property. Suppose we are going to take the value of a as 2, b as -3 and c as say 5. These three are the integers. Now if we are going to take the LHS part, that means a multiplied by b multiplied by c. So it could be written as 2 multiplied by b is your -3 multiplied by 5. So in this case, first of all, we will be solving the bracket. So 5 multiplied by -3 will be minus of 15. It is your minus of 15. Now 2 multiplied by -15 will be your minus of 30. So answer for this LHS part is your minus of 30. Now if we will be solving the RHS part, so value of a is your 2, value of b is -3, value of c is 5. So first of all, we will be solving the bracket. 2 multiplied by -3 will be minus of 6 multiplied by 5. -6 multiplied by 5 will be minus of 30. So here also -30, here also -30. So whatsoever the values of a, b and c is there, for each and every condition, the LHS part will be equivalent to RHS part. So that's the reason we will be saying that multiplication of integers satisfy your associative property. Then comes your distributive property, that is even known as your distributivity. Now, if we are going to say, according to this property, if there are three integers, one is your a, another is b, and the third one is your c. If there are three integers, then a multiplied by b plus c will be equivalent to a multiplied by b plus a multiplied by c. If a, b, c are three integers, then a multiplied by b plus c will be equivalent to a multiplied by b plus a multiplied by c. Similarly, a multiplied by b minus c will be equivalent to a multiplied by b minus a multiplied by c. Whatsoever the value of a, b and c is there, if a, b, c are any of the integer, for each and every case, a multiplied by b plus c will be a multiplied by b plus a multiplied by c, and a multiplied by b minus c will be a multiplied by b minus a multiplied by c. So we will be saying that multiplication of integers satisfy your distributive property of multiplication over addition also and over subtraction also. For both the two conditions, it is being satisfied. Now suppose I am taking the same values. A is 2, b is -3 and c is your 5. So first of all, let's check for your distributive property of multiplication over addition. So here LHS part I am taking first. A is your 2 multiplied by b is -3 plus c is your 5. This is the LHS part we have taken. So if we will be solving it, 2 multiplied by minus 3 plus 5. If we will be adding these two integers, the answer will be your 2. So 2 multiplied by 2 will be your 4. So LHS part is your 4. Now if we will be solving its RHS part, so what the value will be? A is your 2 multiplied by B is minus 3 plus 2 multiplied by C is your 5. So 2 multiplied by minus 3 will be minus of 6. One of the number is positive, another number of is your negative. It will be multiplying these two. Its product will be minus 6 plus 2 multiplied by 5 will be your 10. Now if we will be adding minus 6 and 10, we will be getting 4. So here also it is 4. Here also it is 4. So whatsoever the values of A, B, C is there, always your LHS will be equivalent to your RHS. That means distributive property, distribution is satisfying your integer. It is satisfied for integers, for the multiplication of integers. Now the second condition we are seeing for the subtraction, distributive property of multiplication over subtraction, we is saying that means A multiplied by B minus C will be equivalent to A multiplied by B minus A multiplied by C. We have taken the same values of ABC over here also. So first of all, we are solving the LHS part. So LHS part will be A is 2 multiplied by B is minus 3 and minus of C is 5. So it will be 2 multiplied by minus 3 minus 5 will be minus of 8. Both are negative. So we will be adding it and the sign will be your negative only. So it will be minus of 8. And 2 multiplied by minus 8 will be minus of 16. So LHS part is minus of 16. Now let's check what the value of RHS part is. A is your 2 multiplied by B is minus 3. Minus of 2 multiplied by 5. Wherever A was coming, we have taken 2. Instead of B, we have taken minus 3 and instead of C, we have taken 5. So we will be solving it further. 2 multiplied by minus 3 will be minus of 6. 2 multiplied by 5 will be 10. Minus 6 minus 10 will be minus of 16. So here also it is minus 16 LHS part and in the RHS part even it is minus of 16. So whatsoever the value of A, B, C is there for each and every value of A, B, C, if it is your integers, we are talking about integers only. So whatsoever the value of the integer A, B, C is holding for each and every value, the LHS part will be equivalent to your RHS part. That means integers are following your distributive property for multiplication. Distributive property for multiplication over addition also and over subtraction also. Now the next is your multiplicative identity. Multiplicative identity is, suppose we are saying that A is any of the integer. If we are going to multiply A by 1, the product will be A. And if we will be multiplying 1 and A, the product will be A. That simply means A multiplied by 1 is equivalent to 1 multiplied by A. It is equivalent to your A only. It is equivalent to A. This condition also the answer is A. For this condition also answer is A. That's the reason for every integer the multiplicative identity is your 1. Whatsoever the number is there, whatsoever the integer is there, always and always multiplicative identity is your 1. Now what multiplicative inverse is? If A is any of the integer, then multiplicative inverse will be 1 upon A. If A is any of the integer, then multiplicative inverse will be 1 upon A. Any integer multiplied by its multiplicative inverse is equivalent to your 1. किसी भी number को if we are going to multiply by its inverse, if we have taken any of the integer, suppose one of the integer we have taken as A, so its multiplicative inverse will be 1 upon A, because if we will be multiplying any number by its multiplicative inverse, the product will be your 1. Now if we are going to take A as your 1, so if we will be multiplying 1 by 1 upon 1, or we can say 1 also, product will be 1. That means for 1, the multiplicative inverse is 1 only. For 1, multiplicative inverse is 1 only, because when we are multiplying 1 by 1, we are getting 1. If your number A is minus 1, suppose, then if we will be multiplying minus 1 by 1 upon minus 1, or we can say minus 1 only, then the product will be your 1, because if both the numbers are negative, then also the product is positive. So for -1, multiplicative inverse is -1. For 1, multiplicative inverse is 1. So what we can conclude over here is, if we are taking any of the integer and if we are going to multiply it by its multiplicative inverse, then the product is your 1, that is your multiplicative identity. If this is the condition satisfied, then we will be saying that multiplicative inverse exists. Now up to here we have seen the multiplication of two numbers if we have taken any two integers. Now suppose instead of two integers we are having three integers or four integers or five integers. Suppose we are taking three integers and all the three are negative. Say -2 multiplied by -3 multiplied by minus of 5. Now -2 multiplied by -3, minus and minus, if we will be multiplying, it will become positive. So -2 into -3 will be positive 6, multiplied by minus of 5. 6 multiplied by 5 will be 30. One of the number is positive, one is negative. So final product will be negative only. So it will be minus of 30. Similarly, if we are going to take 5 numbers, say minus of 1 multiplied by minus of 2 multiplied by minus of 3 multiplied by minus of 4 multiplied by minus of 5. These are the numbers. And we are multiplying. So -1 multiplied by -2. Both are negative, product will be positive only. So 1 multiplied by 2 is 2, so positive 2. Then I am multiplying, just keeping it -3 only. And multiplying these two numbers, it is -4, it is -5, both are negative, so product will be your positive. 4 5 is 20, so it will be positive 20. Product of these two will be positive 20. Now we'll be solving it further. One is positive, one is negative. 2 multiplied by -3 will be minus of 6 multiplied by 20. And if we'll be multiplying these two, one is positive, one is negative, so final answer will be your negative. 6 2s are 12, 120. So what we can see over here is, if negative number we are multiplying in odd number of times. Here we are multiplying negative numbers 3 times, that means odd number of times. Here we are multiplying negative integers 5 times, that means odd number of times. So always your product will be negative. If odd number of times we are multiplying negative numbers, then the product will be negative. Now, if instead of odd number of times, we are going to take it even number of times, say 2 times, so we have already seen. Now, if we are multiplying -1 by -2 by -3 and -4, we are multiplying these 4 numbers. What the product will be? -1 multiplied by -2 will be, both are negative, so it will be positive 2, multiplied by -3 multiplied by -4, both are negative, so product will be positive 3 4 is 12, so it will be positive 12, and 2 multiplied by 12 will be your 24. That means if we are multiplying negative integers even number of times, 1 2 3 4, 4 is even number, so if we are multiplying it even number of times, the answer is your positive. Now instead of 4, if we are taking it 6 times, suppose. So we are multiplying -1, -2, -3, -4, -5 and say -6, if we are multiplying these numbers. So -1 multiplied by -2 will be positive 2, -3 multiplied by -4 will be positive 12, -5 multiplied by -6 will be positive 5 6 is 30. Now 2 multiplied by 30 is your 60 into 12. Then it will be 12, 5, 12, 6 is 72, 720. So if we are multiplying negative integers even number of times, the product will be, the final product will be positive. So what we can conclude over here, that if negative sign, we are multiplying negative integers odd number of times, then always the final product will be negative. If we are multiplying negative integers even number of times, then the final product will be your positive. Now let's understand division of integers. So division of integers, we know if there are two integers, suppose we are dividing 8 by 2. The two integers are your 8 and 2. If we are going to divide these two integers, so answer will be your 4. So division of integers could even be said as your inverse of your multiplication. So how we can interpret it? By what number we should multiply 2 so that the product should be your 8. So the number by which we will be multiplying 2 to get 8 is known as your quotient. That means the division, the answer of your division. The number which we are dividing is known as dividend. The number which we are going to divide is known as dividend, and the number by which we are dividing it is known as your divisor. The number by which we are going to divide the number is known as divisor, and the answer for the division is known as your quotient. This is known as your quotient. So when we are dividing the dividend by the divisor, we are getting the quotient. Now suppose we are going to divide any two integers. Now again we are having the two conditions. One condition is when both the integers are having same sign. If both the integers are having same sign. If one of the integer, that means dividend and divisor. Suppose we are taking any two integer. One of the integer is say a and another integer is say b. These two are the integers, and if both the two integers are positive, that means I am taking the same case. If we are going to multiply 8 by 2, both the numbers, both the dividend and the divisor, both are positive, so the quotient will even be your positive. If both the numbers which we are dividing are positive, then the final answer or the quotient will even be positive. Similarly, if both the numbers, that means dividend and divisor, if both are negative, minus 8 and minus 2, if we are going to divide these two integers which are negative, then also the answer will be positive. That means if dividend and divisor, if dividend is positive and divisor is even positive, the quotient will be positive. If dividend is negative and divisor is also negative, then also the quotient will be your positive. So if both the numbers which we are dividing are having the same sign, then the quotient will be positive. Now the second condition is if we are going to divide any two numbers, any two integers, both the integers are having opposite sign. Instead of same sign, they are having opposite sign. That means dividend and divisor, if one is positive, another is negative. Say if we are going to divide minus 8 by 2. So here dividend is negative and divisor is your positive, then the answer will be, your quotient will be your negative. And if your dividend is positive and divisor is negative, then also the quotient will be negative. It does not make a difference whether the divisor is negative or positive or the dividend is negative or positive. If any of these two is positive and another is negative, in both the cases the quotient will be negative only. Like if we are saying if your dividend is positive and divisor is negative, the quotient will be negative. If dividend is negative and divisor is positive, then also the quotient will be negative. That simply means if the two numbers which we are dividing, both are integers, and if both are having the same sign, that means dividend and divisor both are either positive or negative. If both are having the same sign, the quotient will be positive only. And if the dividend and divisor are having opposite sign, any of the one is positive and another is negative, in both the two cases the quotient will be negative. Simply we need to divide the numbers and we have to apply negative sign. Division will remain same as we are doing earlier also, but in these cases, in this case, when both are having the same sign, the answer will be, the quotient will be positive, and when both are having the different sign, the quotient will be your negative. Now let's see the properties of division of integers. As just now we have seen the properties of multiplication of integers. Similarly, we are having the properties of division of integers also. Now if we are going to see the closure property. So what closure property says, suppose A and B are any two integers. If we are going to divide these two integers, whether the quotient will be an integer. So in each and every case, it will not be the case. That means if we are taking, suppose in this case we are taking 8 and 2, these two are the integers, we are dividing it, we are getting 4, which is even an integer. In this case even it is minus 8 and 2, these two are the integers and we are dividing it and we are getting an integer. But suppose the value of A is say 8 and value of B is say 3. if we are going to divide these two integers, 8 divided by 3, so they are not completely divisible, remainder will be there. That means whatsoever the value we will be getting is not an integer. 3, if we will be dividing 8 by 3, so 3 2s are 6, your 2 will be the remaining part, 2, so 20, 3 6 is 18, 3 6 is 18, then again 2, then 3 6 is 18, so it is coming 2.66, and it is not an integer. 2.66 is not an integer. So it is not always the case that when we are going to divide any two integer, then your quotient will always be an integer. It is not the case. So we will be saying that division of integers does not satisfy your closure property. For the division of integers, they are not going to follow the closure property, they are not going to satisfy the closure property, because in some cases the division of the two integers is also an integer, but it is not the case, and in each and every case. Like another example we can take, suppose our number is your say 10, dividend is your 10 and divisor is your 7. If we are going to divide these two, then also our quotient will not be a integer. It will again come in decimals only, it will not be an integer. But if we are going to take say 16 divided by 4, so answer will be of 4, which is an integer. So in some case we are getting the quotient as an integer, but in most of the cases we are not getting it. That's the reason we will be saying that division of integers does not satisfy your closure property. Now let's understand some more properties of division of integers. So the second property is commutative property. So according to commutative property, if there are two integers, say a and b, if a and b are any two integers, and if we are going to divide these two, then whatsoever the quotient will be there, it is not going to be equivalent to b divided by a. If we are going to change the order, their answer, their quotient will not be the same. So we will be saying that division of integers does not satisfy commutative property. They are not going to satisfy the commutative property. Here suppose we are going to take value of a as your say 4 and value of b is say 2. So a divided by b will be 4 divided by 2, that is your 2. And if we are going to divide b divided by a, so it is 2 divided by 4, that is equivalent to 1 upon 2. So a divided by b is not equivalent to b divided by a. So we will be saying that division of integers does not satisfy commutative property. Similarly, associative property, here we are saying that if a, b and c are the three integers, value of a, b and c could be any of the integers, then a divided by b divided by c will not be equivalent to a divided by b divided by c. We can keep the values of a, b and c, and we will be seeing that a divided by b divided by c will not be equivalent to a divided by b divided by c. So we will be saying that division of integers does not satisfy associative property also. Suppose we are going to take value of a as 8, b as 4 and c as 2. Suppose value of a is 8, b is 4 and c is 2, then LHS part will be 8 divided by 4 divided by 2. This will be the LHS part, and its value will be 8 divided by 4 divided by 2 will be 2, and 8 divided by 2 will be your 4. Now if we will be taking the RHS part, so RHS part is 8 divided by 4 divided by 2. 8 divided by 4 will be 2 and 2 divided by 2 will be your 1. So here LHS value is your 4, quotient over here is 4 and value over here is 1. So LHS part is not equivalent to RHS part. So we will be saying that division of integers does not satisfy associative property. Similarly, division of integers does not satisfy distributive property also, neither for addition and nor for your subtraction. That simply means a divided by b plus c. It will not be equivalent to a divided by b plus a divided by c. It is not going to be equal. Similarly, a divided by b minus c will not be equivalent to a divided by b minus a divided by c. Suppose value of a, b and c are these only 8, 4 and 2. For this condition, for addition, we are keeping the values, we are finding the value of your LHS part. So it will be, instead of A, we will be writing 8 divided by B is your 4 and C is your 2. So 4 plus 2 will be your 6. So it is your 8 divided by 6. 8 divided by 6 it will be doing. So it will be 4 by 3. 8 upon 6 we can write it as 4 upon 3 also. Now if we are going to solve this part, RHS part. So A is your 8. 8 divided by 4 plus 8 divided by 2. 8 divided by 4 is your 2 plus 8 divided by 2 will be 4. Value will be your 6. Here it is 6, here it is 4 upon 3. Both are not equal. Similarly, we can check it for subtraction also. So we will be saying that integers, division of integers does not satisfy your distributive property. Now identity for division. Now for identity for division even, so identity for division does not exist. Why it does not exist? Suppose I am going to say that A is any of the integer. So if I will be dividing A by 1, we will be getting A. And if we will be dividing 1 by A, we will be getting 1 upon A. So both are not equal. That's the reason identity for division does not exist. Similarly, inverse of division also does not exist, because if we'll be taking any of the number, say any of the integer is A, if we are going to divide it by 1 upon A, we are not going to get 1. So that's the reason inverse of division even does not exist. Now some more properties of division is there. If there are two, say A is any of the integer which is a non-zero integer, the value of A should not be 0. If it is not equivalent to 0, then if we are going to divide A by A, always the quotient will be 1. So if I am saying minus 3 is one of the integer, and if we are going to divide minus 3 by minus 3, we will be getting 1. So if A is any of the integer whose value is not 0, value should not be 0. In that case, if we are going to divide the number by itself, we will be getting 1 as the quotient. Similarly, if A is any of the non-zero integer, and if we are going to divide 0 by that non-zero integer, say the value of the integer is say minus of 5, the answer will be, the quotient will be always 0. So 0 divided by any non-zero integer will always be 0. And if we are going to take value of A as any of the integer, here it could be 0 also. So if any of the integer, say minus of 10, if we are going to divide it by 0, always the quotient will not be defined. The value will not be defined. So these are some of the properties related to division of integers. Now let's understand what is DMAS rule. Till now we have seen separately if we have to add two integers or subtract two integers or multiply or divide two integers. But if these operations are all together, that means instead of only one operation, we are having more fundamental operation. What fundamental operations are? Addition, subtraction, multiplication, division. These are the fundamental operations. So if instead of only one operation, there are multiple operations in any of the given expression, then how we can solve it? So first of all, what we'll be doing is D represents your division, M represents multiplication, then addition, and then your subtraction. So whensoever we are having multiple operations in any of the given expression, then first of all we will be dividing it. First of all, division will be done. First of all, we will be dividing it. First of all, division, then operation of your multiplication. Then second operation will be multiplication. Then it is your addition, and then it is subtraction. So how we will be applying it? Just let's understand it. Suppose this is an expression, we have to solve it. In this operation, addition sign is even there and your division sign is even there. So first of all, according to your DMAS rule, first of all, division will be done. Division will be done. That means first of all, we will operate this part. So it will be minus of 4 will be written as it is. This plus sign will remain as it is. If we will be dividing minus 12 and minus 6, so both are negative. Your dividend is even negative and divisor is even negative. So your quotient will be positive. Minus 12 divided by minus 6 will be positive 2. So here it will be positive 2. Now we have to add. One of the integer is negative, another integer is your positive. So what we will be doing is we will be adding, we will be subtracting these two, minus 4 and 2. So 4 and 2, it will be your positive 2, but negative number is greater than your positive number. So final answer will be minus of 2. So minus of 4 plus 2 will be your minus of 2 will be the answer. If we have to add any two integers which are having the opposite sign, so you must be knowing that what we have to do is we have to subtract the numbers, but whatsoever the number is having the greater number, whichsoever the sign they are having, we will be applying that sign. Here 4 is greater than 2 and 4 is negative. That's the reason the final answer will be negative of 2. Now the second question over here it is multiplication of these two numbers and division of these two numbers. So first of all we will be dividing it and then we will be doing the operation of multiplication. So first of all let this minus 20 multiplied by minus 1 plus 14 divided by 7 will be your 2. So it will be 2. Now we will be multiplying it. Minus 20 multiplied by minus 1. Both the integers are negative. So final product will be your positive only. So minus 20 multiplied by minus 1 will be positive of 20. 20 plus 2 will be your 22. So if there are multiple operations in any of the given expression, then we will be following this rule, DMAS rule. That means first of all division will be done, then multiplication, then addition and then subtraction. Now let's understand how to remove the brackets. Earlier we have seen that if in any of the expression multiple operations are there, then what will be the sequence of solving these operations? First of all division, then multiplication, then addition and then subtraction. But if in any of the expression multiple brackets are there, then what will be the sequence of removing the brackets? So first of all, we will be removing the vinculum. We will be solving the vinculum first. After that, we will be solving the small bracket, which is even known as parenthesis. After that, we will be solving the curly bracket or middle bracket. And then we will be solving the square bracket. Now let's see how it will be done. So if we have to solve 35 minus 15 plus 14 minus 13 plus 2 minus 1 plus 3, brackets are there. First of all, what we will be doing? First of all, we will be solving the vinculum. That means this part will be solved earlier. Rest all the numbers we will be writing as it is. 35 minus 15 plus 14 minus 13 plus. First of all, minus 1 plus 3. If we will be adding these two integers, minus 1 plus 3 will be plus 2. Plus 2 plus 2 will be plus of 4. That means it will be your 4. This portion if we will be solving, it will be plus 4. Now vinculum is done. We have taken all the brackets. Now we will be solving the small bracket. So rest all the numbers we will be writing as it is. 15 plus 14. Now 13 plus 4. 13 plus 4 is 17. So minus sign is outside it. Minus of 17 we have written. Now small bracket is done. Now we will be solving the curly bracket. So 35 minus. It is your 15. 15 plus 14 will be your 29. 15 plus 14 will be your 29. If from 29 we will be subtracting 17, we will be getting 12. So we will be taking 12 over here. This bracket is even done. Now 35 minus 12 will be your 23 will be the answer. This is how using the sequence we will be solving the expression. Now let's see the next question. It is 45 minus 38 minus 60 divided by 3 minus, this is the given expression to us. We have to solve it. Here vinculum is not there. So first of all, we will be solving the small bracket. Now rest all the numbers, we will be writing it as it is. 38 minus 60 divided by 3. Now see, it is minus 9 divided by 3. Here, first of all, we won't be doing the subtraction. We will be dividing it first because sequence we need to follow. So minus 9 divided by 3. One of the number is negative, another number is positive. So final, your quotient will be negative. 9 divided by 3 is 3. So minus sign will be there. So minus of 6 minus 3. Minus 9 divided by 3 will be minus of 3. I have written it. Now we'll be solving it further. 45 minus 38 minus 60 divided by 3. 6 minus 3 will be 3. So minus sign is outside it. So minus of 3 divided by 3. Now what we need to do is, now we need to solve the curly bracket. Small bracket is done. Now we need to solve the curly bracket. So 60 divided by 3. 60 divided by 3 we will be doing, that will be 20 minus 3 divided by 3, minus 3 divided by 3 will be minus of 1, so minus of 1 written. Right? 60 divided by 3 we have done, that is 20. Minus 3 divided by minus 3 will be minus of 1. So this is the part. Now we will be solving it further. 45 minus 38, 20 minus 1 will be 19. So minus of 19. Now we'll be solving the square bracket. So 45 minus 38 minus 19. 18 minus 9 will be your 9 only. Then it will become 2. 2 minus 1, it is your 19. Now 45 minus 19 will be 15 minus 9 will be your 6. It will be 3 minus 1 will be your 2. So final answer will be your 26. So we will be following the sequence in the brackets. First vinculum will be solved, then small bracket, then curly bracket, and then small your square bracket. In this also, if multiple operations are there all together, so first of all we will be solving the division. First of all division will be done, then multiplication, then addition, and then subtraction. Till now we have seen that if any of the expression is given to us, how to solve it. Now if the word problem is there, then how we will be framing the expression and we will be solving it. Let's understand it. So if the sum of two integers is minus 15, if one of them is 9, find the other. This is a problem given to us. Now first of all we have to make an expression for it, and we will be solving the expression to find the value of the unknown. Here we are assuming that the other number which we have to find is your x. Let the number be x. Now what is given to us, that the sum of two integers is minus 15. So we have assumed one of the integer to be x. Another integer is given to us as 9. That means sum of x and 9 is given to us as minus of 15. That simply means, according to your question, x plus 9, it is equivalent to minus of 15. Sum of two integer is minus 15. One of the integer is 9. So we have taken another integer to be x. One of the integer was given to us as 9, and sum of these two is equivalent to minus 15 according to the question. Now if we will be solving it further, what the value of x will be? It is positive 9. It will go in the RHS. It will become negative 9. So it will be x is equivalent to minus of 15. This positive 9 will turn to minus of 9. So value of x is minus 15 minus 9. So if we will be adding these two, 15 and 9, it will be your 24, because both are negative. So it will be minus of 24. So value of x will be minus of 24, or we can say the another number is your minus of 24. Or we can say, if we are going to add minus 24 and 9, the sum will be your minus of 15. The next question is, the difference between two integers x and minus 8 is 15. Find the value of x. Now over here, two integers are there. One is your x, another is minus 8. Difference between these two is given to us as 15. We have to find the value of x. We have already learned in our previous classes that integers does not follow commutative property for subtraction. That means a minus b is not equivalent to b minus a. They both are different. That means if we will be subtracting x from minus 8, the answer will be different. And if we will be subtracting minus 8 and x, the answer will be different. They won't be same. So we will be taking two conditions. In one of the condition, we are subtracting from x, we are subtracting minus 8, and the result is 15. When we will be subtracting these two, from x we are subtracting minus 8, we are getting 15. In another condition, from minus 8 we are subtracting s to get 15. So we will be getting two different values of x from here. First we are solving this part. X minus multiplied by minus will become positive 8. It is equivalent to 15. So value of x will be 15 minus 8, or we can say value of x is your 7. So one of the value of x is 7. From here, what the value of x will be there? Minus of 8 minus of x is equivalent to 15. This minus x, when will go over here, it will become positive x, and this 15, when it will come in the LHS, it will become minus of 15. So it will be minus of 8 minus of 15, it is equivalent to x. Minus 8 and minus 15, if we will be adding these two, 15 and 8 will be your 23, because both are negative. So it will be minus of 23. It is the value of your x. That means if from 7, we will be subtracting minus 8, we will be getting 15, and from minus 8, if we will be subtracting minus of 23, then also we will be getting a 15. So the values of x could be 7 or minus of 23. In the case of subtraction, in these type of cases, we will be having two different values of x. So this is all from this chapter, integers. Hope it is clear to you that if any two integers or more than two integers are given to us, how we can multiply it, how we can divide it. If any of the expression is given to us, how we can solve it, how we can remove the brackets, all that must be clear to you. Soon we'll be coming with the more videos of class 7th maths curriculum. Till then, thank you.